Hello, hello.
Hello.
Welcome to 2025. Today it's only two of us, Andrei and Vladimir.
Hello.
And today we have a presentation. What was the presentation title, Vladimir?
It was like as why is RDS not just the open source PostgreSQL, and some small history from the classic RDS to Aurora DSQL and the options which we have to run PostgreSQL in AWS.
Right. There's a little bit of background to this.
Yes.
Vlad is back from Singapore, where he did the presentation. And we thought we have the slides. Why not to share it with a broader audience so you all can enjoy and learn something new?
Yeah, we feel like it's how it was.
That's Vlad in Singapore.
Yeah, it's true, and with AWS community in Singapore. So.
Yes.
And if you are in Singapore and you're watching this video, just type us, let us know somehow that video reach you. Probably
we send you our love if you are in Singapore and you attended Vladimir's presentation.
Yeah. So, but world is quite small time to time, and there are not that many engineers who go deeply in some specific services, so you can actually meet each other virtually.
Right. So, shall we?
Yes, we can go. I have some slides, but I not will do like exactly one-to-one presentation here, because maybe it will be too long to view inside the video. But I have a blog post which we will share in the description of the video, so it's more details there.
All right.
Let's just go through. So. Yeah, you already know who I am. I'm Vladimir Samoilov, AWS community builder, and I like to create funny titles for any kind of CTO word. This time it was a chief translation officer. It's a person who, translate business things to infrastructure things. So kind of that. And it was like a kind of a takeaways, but it's what we're going to see today. It's a small history of PostgreSQL, where this is beyond mentioned PostgreSQL, different options of PostgreSQL, and more PostgreSQL, and Aurora DSQL, of course. So, but keep look inside the name, Aurora DSQL, and later we will know why it's called DSQL and not something else. So for the open source and self-managed Postgre, maybe Andrei knows that some people called PostgreSQL Postgres. Do you know that thing, Andrei? You heard from someone?
I'm one of them.
Yeah, but there is some story behind that actually, because the original name of PostgreSQL, as me, I like to call it Postgre, it's called Postgres. And it was related to Ingress. It's another database system. You can find it in the Wikipedia. It's called Ingress. But after a while, team decided to change it to PostgreSQL to like focus the name to a SQL. So, and it's go that way maybe for last 20 years, I guess. And PostgreSQL is actually a project with nearly 30 years of active development. And today we are going to look all of these 30 years of a PostgreSQL. No, is it just
20 minutes?
Yeah, 20 minutes. 30 years and 20 minutes. But yeah, we will focus on a modern history, of course. And what we should mention here that many different companies and individuals around the world is contributing to PostgreSQL project. And especially AWS, they contribute a lot to logical replication and an extensions, especially to PG vector, which actually makes possible to use PostgreSQL as a vector database for Amazon Bedrock. So it's a huge contribution from the AWS. So let's just continue. But here's about the typical problems with the self-managing PostgreSQL, but you probably already know all of them. But I would like to mention that the problems are bigger and bigger each year because we have more data to manage. We have more environments. We have more database servers. Actually, it means all of these problems are multiplexed across a number of servers, environments, and so on and so on. And usually in bigger companies, there's a person responsible for databases or a department or any more departments responsible for databases. But for startups and scale-ups, it's a bit more challenging, but you're out of people, so you don't have that, departments. And usually you just select some developer who just know more about the databases, and that person become, the developer and the database administrator at the same time. But all of these problems, it's what AWS are focusing on when they create Amazon RDS for PostgreSQL. But actually, in the beginning, it was just MySQL only in 2009. It's only MySQL first, and only after a while, after 4 years, PostgreSQL appear. But AWS is focusing on all major problems, like multi-AZ deployments, backups, all of them, like make lives of everyone easier. And also during this time, it was maybe don't have another slide, but okay. So during that time, it was a lot of concern about what. So just a moment. Yeah, after a bit more time, a bit. It's how many? 4 years, right? 4 years it's take to go to the next step. It's 4 years of RDS for PostgreSQL only in AWS. And only in 2017, Aurora PostgreSQL appeared, and it's how it looks in the past, the dashboard. So it was not that beautiful during that time, but it was PostgreSQL version 9, and it was a lot of concerns and questions, which versions of PostgreSQL I have to use, what to run, because it was a difference during that time. But today, it's we have PostgreSQL version 14, 15, 16, and beyond that. And I think that Aurora PostgreSQL can be a default choice for all modern cloud projects. If you don't know what to choose, you can choose Aurora PostgreSQL without any problems, because it's the same as RDS for PostgreSQL. I don't see the difference. So, and I suggest to go with Aurora as a default option. And this is actually why, because we have a different, maybe like that, it's a bit better. We have first decomposition inside the database engine. It's first decomposition when Amazon or AWS split the compute and storage. It's happened in Aurora. And based on that, we have a separate compute. It means we can make any experiments with the compute part. Andrei, we can actually run the Postgres Aurora without any compute. We can run a headless cluster. You don't need a compute at all.
I heard about that, but I haven't experienced it myself.
You can try, and you can remove all the compute engines or at all, and just leave your storage. For example, it's allow you to save in a development or in hobby projects, because you pay only for storage, you not pay for compute entirely. So, and it's also allow everyone to experiment with different computes, maybe T-type, M-type, C-type, whatever you want. You can try many. And the storage decomposition of a storage, it's also allowed to use a shared storage architecture, as we see in this diagram. Storage is distributed automatically. If we compare with Amazon RDS for PostgreSQL, storage exists only where the database instances exist. Without multi-AZ, we have only one AZ, and that's it. Here we can have a distributed storage. If one AZ goes down, we still have our data. It's not disappear. And it's a magic because under this storage system is actually S3 in end. I don't know exactly how, but there's the S3 somewhere. So why it's so fast and why we can use Aurora fast database cloning feature, for example, for cloned instances or point-in-time recovery. We can go back in time to a specific moment and restore from that time. It's all thanks for a storage subsystem of Aurora. But key point here is a decomposition. So first, decomposition. Now we have two layers of database system, the compute and the storage. Amazon Aurora, the serverless part. Oh. Yeah, the serverless. In the past, it was a version 1, which probably wasn't that popular and doesn't scale that fast as version 2. But version 2, for a while, right, for a couple of years, was only possible to scale to a minimal size, but not to 0. But in a recent reinvent, AWS announced that it's possible to scale to 0, right? So you can try run some dev environments and it will automatically scale to 0 if no one uses it. But if I understand correct, in a world, in a community, and so on, cost is still remain a concern because it's more expensive, obviously, than just provision instances. So, but there's a way how to calculate that. We can get all the metrics of a database and actually run some script, some automation, and try to estimate how much it will cost for provisioning instances. For serverless, we can compare. But for serverless v2 or for Aurora serverless, it's required to have a special case. Without a special case, it's probably not the point to using that at all. For me, I find the case when Aurora serverless v2 help to handle a completely unpredictable workload, like as cryptocurrency price changes. When market is spike, what everyone would do, maybe open their portfolio, open the app, show the graphs, how good I am, how much I get. And yeah, it's, in the end, it actually comes to database and ask the information about the portfolio and calculate the graph. So when it's happened, I guess no one know.
I think just small note here that usually in the project where the price is a hard constraint, performance is less so. So it's usually someone who is scaling up, they need to have at least some kind of database. And then you can just build your own Aurora. I mean, get EFS, put your data there, and then run the database in containers on ECS. Pabam, you decouple the compute from storage. Storage is highly distributed and available. Your containers are highly distributed and available. The performance would suck big time, but if your priority is the cost, I would argue that might be the most cost-efficient option on AWS, if you're ready to sacrifice performance.
Yes, if you don't need performance, yeah. But it's a good option. So yet another option to run PostgreSQL inside AWS, build it on yourself. So, but behind the serverless, there is some changes inside the architecture, and it's another component that AWS introduced. It's a request routers. We, as a customer, we didn't see the network load balancer or VPC endpoints or request routers. We not see that entirely, but it exists. It means same. It's another layer in the decomposition because AWS need a way how to distribute, the load across the real instances. Because someone still have to run them, even if we as end customer don't run them. But it's a 3 layers since the serverless. It's a request routers, instance, and storage. So another layer for decomposition. If we have a reference to this magic thing with EFS, I guess we have to put NLD in front, right? And we get it 3 layers as well. So, but yeah, this is the point here of using the serverless. It's another global database, which probably wasn't that much popular until the global writer is announced. It means now we're able to automatically redirect the writes to a writer region with Aurora Global Database. But here's a kind of important moment. We don't need to look inside this scheme. It's about Aurora Global Database. But this is a tiny orange boxes inside the scheme that you can see. It's a replication servers. It's another component that AWS add to Aurora ecosystem. And this component allow to replicate data between regions in milliseconds, which is, for me, it's quite impressive. Because in a European region, we're able to achieve lower than 50 milliseconds replication delay, which is impressive. I think if we calculate, if we do the math, maybe it's nearly speed of light, maybe, right? That fast. Because if you try to connect to regions directly somehow with VPC and so on, you don't get this speed. So it's actually another way of connecting. So some custom way.
I would say global database had its evolution across the last couple of years, because initially when they released it, you had a fallback or like switchover procedure, and you would have a different writer endpoints in all the regions, and you need to orchestrate that a little bit. So like where you send the traffic when you do the database switch over to another region, and the app need to have the proper writer endpoints that will not be available if that region is not active. So it was a little bit of cumbersome, and you needed to put a little bit of glue on top of it to make it all work and do the switchovers automatically. Still, those switchovers were very, very fast. I mean, if you accept the data losses, you could switch over within like seconds. If not, that would take minutes, but still it will be like 5-6 minutes, no longer than that. Like in my personal experience, I mean, if you tune it up correctly, you might be able to do it faster. So, but now they did introduce first write forwarding, so which made it much easier. And now, like with the latest announcement, now they have a global writer endpoint, so you don't need to configure applications differently between regions. They can all use the same connection string, which is very, very, very convenient, and makes the switchover procedure less intrusive from the application perspective, and there is less to orchestrate for us as a builders.
And I think it's what people actually, expect from a global database that you will automatically somehow handle it for you.
Well, yes, when I started with the global database, that was my expectation. There would be some kind of global endpoint that I could use, but it was none, and it was cumbersome. I think now it's actually a time to go and give it a try.
Yes, right. So another thing that we have to mention, maybe tiny and not that popular service, it's Amazon Time Sync service, which had like a huge evolution in a previous year with a microsecond accurate time. And it's public available. It's time.aws.com, so we can use it to sync our watches, around the world. And it will play a critical role inside the next service. So keep this in mind. Limitless, more Aurora. If you think like it's how many of Auroras could be, there's another one which become GA. But for us, the most important thing is the architecture diagram, because it's clearly show that a shard is contained with distributed transaction router, data access shard, like a SQL engine shard, and Aurora storage. So it's clearly 3 different layers here. And if we compare serverless, limitless, limitless is just a serverless which can scale for write and reads, like it's for whatever you need. You don't forget about it at all. But there's many limitations in limitless. So if you really need that, you have to go and read the limitations. But I think it will be less and less of them as soon as this project become more popular. So, and I think now it's have a bit more thing about the PostgreSQL. Why I have to mention that? Because there's a huge upgrade related to a logical replication, because since PostgreSQL 17, if you would like to perform a major version upgrade, we don't need to recreate a logical replication slot. What does actually mean?
This is huge.
Oh yeah, right. Because it's a bit boring. Because if you want to, perform a major upgrade, you have to go destroy a replication slot, make a major upgrade, create it again, and resync all the data. So
if you have DMS jobs running out of your database, you are screwed because you need to recreate the replication slot. So it makes all the upgrades a very nervous and sensitive operation. And I know because I know the person who did it a couple of months ago.
Yes.
Doing upgrade from 12 to 16, I believe it was. So it wasn't 17, and he had to go and do exactly that. Which means that with next upgrade, well, probably you still need to recreate them when you upgrade to 17, but after, your life is easier.
And if I understand correct, this was a huge contribution from AWS. And when I see all of this news together, like I said, time sync, logical replication, the limitless, serverless thing, it's something kind of pop up in my mind. But AWS
something is cooking.
Yeah, something is cooking somewhere. And you also know that Google Cloud Spanner is somewhere around. And there's no alternative in AWS. And if you glue with all of things together, you think, yes, something is big happening maybe soon. And yes, on reInvent, it was announced Amazon Aurora DSQL, and we have to pay attention at the name. It's not called Amazon Aurora distributed PostgreSQL, for example, or not Amazon Aurora active PostgreSQL. No, it's called Amazon Aurora DSQL. And name is important here. We will see it later on. And it's free now. Available in 2 regions in US. You can try it for free, and it's could let you have an experience with Aurora DSQL before you really consider of choosing that or not. But before we go to this underlying architecture of DSQL, we have to remind ourselves about what we expect from the transaction in a relationship database. We expect that the transactions happen or doesn't happen at all. We expect that the database must be consistent between transactions, and transactions must be isolated and not interfere with each other. And we expect the durability. The data is actually appear in the database. It's what we expect from the PostgreSQL, what we expect from a relationship database. And by thinking about that, AWS designed this multi-layers architecture. Some of these layers we already know. The transaction and session router, we saw it already in a serverless. You remember it's already have these layers. Query processor. Query processor, it's basically a PostgreSQL protocol which wrapped inside the Firecrackers VM, which is quite impressive how AWS keep reusing the existing primitives like it's lambdas. So we can see here it's a NLB, Lambda, S3 somewhere, things which already exist. Everything is built on Rust. There's some meme in internet. Let's rewrite it in Rust, right? But here's a good case. It's a good choice, and I think Rust is a language we're supposed to use in these highly available distributed systems. But there's a couple of components which AWS add here, the specific components, like as adjudicator. It's implement a distributed commit protocol to manage isolation and ensure the consistency without require coordination before commit. It's a special component that AWS designed. Journal, it's a log as database layer. AWS already talked about a log is a database thing in a previous reInvent, and here is the continue. And it's provide the atomicity and durability of a transaction. And the storage is just optimized. It's not, if I understand correctly, it's not exactly the same as Aurora storage. It's a new one, and it's optimized to minimize the trips between application database engine. It also have upgrades related to indexes and the fast query performance. So it's designed for execute specific transactions. It means AWS here perform a decomposition of PostgreSQL itself. We split it in the components. And magic happen related to read requests, because all the read requests come to the query processor and then directly to the storage. So there's no coordination between all of these components at all for read requests. So I expect that the read performance will be very impressive, and we can read fast as possible. For writes, yes, obviously we need a coordination, but all the coordination happen only at the commit time. So everything what we execute before the commit in SQL transaction, it will just happen in parallel, but when time to commit, we need to coordinate and actually decide what we need to commit. How AWS handling the split brain thing? Because we see it's 2 regions, but it's actually 3 of them. Because I think like if one region is it's X-effective system, right? And if network connection between 2 regions is interrupted, how we know which region have data? Because they both X-effective, they both available. How to know? Well, it's obvious they introduced the 3rd region. It means technically for run Aurora DSQL, you need 3 regions, not 2 regions. And it's another witness region. And yeah, by using that, the system become much more obvious. Like I say, if region C is a lost connection to A and B, obviously it's have only 1 journal service available, and A have 2 journal service available, A and B. So we know region A is working well, region C not, let's shut down it. So, but it's 3rd region, it could be challenging for the countries who don't have many regions inside the country yet, maybe 2, but 3rd region, where I get that one. But by architecture, if I understand correct, there is no storage inside the 3rd region. It's just a witness region, so there's no storage there. Maybe it's fine for data residency thing. Maybe it's fine, but I guess it will work pretty well in US, because in US we have 4 regions,
4
right?
regions, yeah.
More than enough to run Aurora DSQL.
Let's see how they will roll it out. So we will, I guess, see it with the rollout where it becomes available.
Yeah. It could be interesting. So for security, we like security part, and I like how it works inside DSQL, because all the encryption exists just by default. At least for the preview, there's no way around. You can't disable encryption at rest. You can't create the DSQL, this is not encrypted. So there's no more recreation of database if it's not encrypted. You can't disable or forget to enforce encryption in transit. It's enforced by default. You must use a TLS SSL connection to actually access the database. And other services like IAM is work pretty good. It's have a lot of conditions already, but I guess it will be more. It's now still preview, so I expect more in the future. There is no AWS backup at the moment, but I think it will appear. So I expect something happen after the preview phase. For authentication and authorization. So first, what we have to mention, it's a separate IAM actions for admin role and for the rest. Because if someone uses RDS IAM auth, there is just DB connect, if I remember right. There's no options. Here is a 2 separate thing. You can allow someone to connect as admin and allow the rest of the people connect as other roles which you create as admin. So you have a full control of that thing. And yeah, no passwords at all.
No static credentials, only RDS IAM auth.
Yeah, some alternative. But at the moment in the preview phase, there is no way to create a static password at all. So I let it be. Don't need.
Yes. Who needs that?
Who needs it? So, and this is how we connect, and it's remind me a lot about RDS IAM auth. You have to get token, then enforce the SSL and just get connection. For us who using RDS IAM auth, it's pretty obvious, but who doesn't? So please keep attention to that. But the good point here, AWS add the button in UI, generate the token, the connect button. You don't need the CLI. It's much more simpler. You click the UI button, you get the password, and you can connect. And another point is expiration time. In a RDS IAM auth, just 15-minute fix it. Here is up to 1 hour, and you can make a setting on your own, how long you need it. So it's a good one. So for the quotas, you don't need to actually cover that because I expect it will change. So, but you have to keep in mind that at the moment you can have only 1,000 connection maximum to the cluster and no more than 10 or 100 in burst rate per second. So how fast you connect. The same limitation exists in RDS out as well, but I think it will be like changing to bigger values after the preview. But the important part here is Aurora DSQL error codes. Aurora DSQL provides you the numbers, the information, so you will know at least what's wrong, and you can, handle it inside your code. Primary
What
keys.
about the storage size? If you go back, it says 100 gigabytes per cluster.
Yep.
That's it. So like,
yep.
The clusters are separate. You cannot add more instances to the cluster and then increase the storage.
No, but it's configurable, so we can increase it with the support. I believe it's why not stop much.
Right.
And
it's default limit, right?
Yeah, default 100 gigabytes.
It's not a hard limit, basically.
Yeah, it's not a hard limit. But hard limits here, if you touch that, hard limits, it's a maximum connection duration, it's 60 minutes, and the maximum transaction time is a 5 minutes. But I can understand maximum transaction time 5 minutes. We have the exact same value as a default inside our production database, because if it's happened longer, there is no sense to continue that transaction. The data is already changing. It's a distributed system. Make it faster and shorter. 5 minutes is too much. But yeah, 100 gigabyte. Primary keys. Yeah, the funny moment that even if you create a table without the primary key in Aurora DSQL will create the key for you and will not show for you that key. It will be a hidden ID. Because it's how distribution system works. Aurora DSQL use the primary key to create a cluster-wide key and distribute the data, and it's basically how logical replication works inside the PostgreSQL. We must have a primary key to perform a proper replication. So, but if you create the tables, please create them with a primary key, because you can't add it later. Aurora DSQL do it for you. You can change it and you can add it. So you have to recreate the table. Funny. And also here is a different way how to use sequence in a primary key. In the documentation, the SQL suggests us to use any kind of random value in primary key to distribute our data across the storage nodes naturally. Because I expect the SQL use the primary key to split everything across different storage nodes. If you use just 1, 2, 3, 4, 5 to 100, maybe everything, all the data comes to the same storage node and it just gets overloaded.
So you remember S3 had that issue. If you have the pass, you will be limited, like all your read operation will be limited by the pass. Yeah. I wonder if the primary key is a pass on S3 somewhere. I think they did fix that pass issue, but I heard that some people were still encountering it. And yeah, interesting.
It could be very related. And also documentation says, but if you try to create some read-only table or read-most table, you can use with 1, 2, 3, 4, 5 keys. But I expect we have to use a random UIDs inside the primary key if you want to use Aurora DSQL. And maybe avoid the sequence in general. So there's more limitations related to primary key, but they're in documentation. So please read it. So you can use specific number of columns, specific size of primary key, and so on. So just read the docs. The bad side, it's unsupported features, at least for now, at least in January 2025 during the preview. There is no trigger, sequence, fragment keys, and so on, temporary tables views. Basically, it's a bit hard to make a drop-in replacement for a PostgreSQL to Aurora DSQL, because usually people use all the features of PostgreSQL. So, but sequence I can understand, because it's painful inside the PostgreSQL world to replicate the sequence. Inside the logical replication does not exist, because during the logical replication, PostgreSQL actually write data as it is to the destination without triggering the triggers and actually trigger the sequence counter. So maybe this is not supported yet. Maybe it appears in the future. I don't know, but it's challenging for PostgreSQL itself.
It's with everything in life. You cannot have everything.
Yes,
you get a magical database that magically distributes your rights and works in all the regions. It cannot work as your local database, so there should be some kind of balancing of the functionality. You get something, you lose something. That's quite often. This is how it is in life.
Right.
So the balance.
How DSQL works with the transactions, as we talked before, it's a query engine. And query engine, if I understand correct, it understand which SQL construction comes. Then first, what AWS already understand is a DDL and DML operation. Like as DDL, it's a creation tables, for example, creation columns, and we can't mix them together. But I understand that because for DML operations, select, update, insert, and so on, they could be easily replicated with a logical replication to another nodes. But for DDL, create tables, and so on, it's not supported by default in logical replication. You have to create a schema in another place and blah, blah, blah. But here it's happened automatically. It's good, but only one DDL per transaction. So for
What
me...
What is DDL? It's not the Windows dynamic library.
No, it's not a Windows dynamic library of code. It's DDL. It stands for data definition language, and it's create table, create column, alter table, and so on. So,
Okay.
but it's definitely AWS did something for replicate all this schema across all the nodes and let all these engines use the schema together. So it's something underlying, it's something custom. But what we have to keep in mind, at least for preview, I don't know how, but transaction cannot modify more than 10,000 rows in one transaction. How I have to predict that? Just to keep a limit in every transaction?
That would be hard.
Yeah, but I expected just for preview, for let everyone try DSQL just to avoid heavy transactions maybe and overload the entire system maybe. And also, if you have secondary indexes, you can have even less rows and so on. But I think it will be removed as soon as the preview phase is passed. So, and there's even more limitations in Aurora DSQL. So please take a look inside the documentation if you find some strange errors. But Aurora DSQL responds with the proper error codes and error messages, which is good. You at least know what's happened. What's good? It's behave as a PostgreSQL 16. All the drivers, all the tools, all the favorite DB viewer and UIs and drivers, everything works well. And all the selects, inserts, joins, the basic operations also works well. And if you use PostgreSQL as a very straightforward, is if all of your logic is mostly inside the code, it's probably a high chance that you can use DSQL as a PostgreSQL replacement. Because you don't do is triggers magic somewhere. If you insert records here, trigger that function and that function, insert records in another table and continue it.
Don't do stored procedures. Don't do stored procedures. It's like always ends badly. Like it sounds as a good idea, but it's not. Just don't do stored procedures. It's hard to test, it blows in your face. It's just like, it's tempting. You know, it's like eating chocolate. You know it's bad for you, but you keep eating it. Like, don't do stored procedures.
Yes, it's like I said, it's hard, and it's also hard for DSQL. So, but and also many systems views and system tables is available inside DSQL. So if someone want to see the configuration of DSQL, you can call the system calls and see it. So it's possible. It's quite interesting. So the next thing, it's about the concurrency control in DSQL, which is quite important because here Aurora DSQL using snapshot isolation and optimistic concurrency control. What it means? It means if two transactions come in the same time, who executed first win. The rest have to retry the transaction. And it's means it's easier to understand, like as who comes first is done. There is no logs and so on. And there's a lot of debates inside the PostgreSQL world. If you are a database administrator with nearly 30 years of experience, you will definitely comment something here in YouTube. So like a snapshot isolation is bad, serializable isolation is good, or so on, but we not that deep in databases. And we know that AWS find a snapshot isolation as a sweet spot because it's help with concurrency. It helps to make a system fast. And in case of conflict, we just retry. So, but this is not possible to avoid conflicts entirely, like a serializable isolation. But with serializable isolation, the system will be not that fast. That's what I would like to say here. But yeah, it's this is mostly for true nerds who know about the Postgres.
Basically, choose your use case. What works for use case? It's all very use case dependent. Some workloads can tolerate the conflict, some cannot. For instance, financial transactions, maybe you don't really want to have the conflicts there.
Yeah. And if I understand documentation correct and the tests and so on, AWS is kind of planning to add another types of isolation to DSQL. It's not yet announced. I just find some parts in the documentation. Maybe if you have a requirements for serializable isolation, you probably have to let know AWS, we need that. We have a huge customer who need this, and I expect AWS just add that. Testing. I test DSQL myself. First impression was very nice because cluster appear very fast. Usually when I make tests with Aurora, I just click the cluster and then just do something else because it takes 15 to 20 minutes to create. Here it just magically appear in less than 5 minutes, maybe 3, 4. And we get a very nice new URL with new domain on AWS. The new one looks pretty nice. But endpoint itself, it's now set of random digits. Maybe it's a preview phase. Yes, as I mentioned before, the temporary token generation is in UI. And this is some example of a system table. So benchmark. I try to run the provided benchmark by AWS, but to be honest, I not understand it at all. It's again for true database experts how to make interpretation of this. But what I get it from that benchmark, but it's quite small. It's require much bigger scale factors to understand the true difference, because there's a public tests available with much larger numbers. And what else I understand, that we need our own use case. This benchmark doesn't show anything. You need definitely your own use case, your own SQL, your own database schema and tables, and run that against the SQL and see what's happening.
Yeah, that's how I see it. So the DSQL is not a replacement for all the databases out there. It's very specialized tool for very specialized use case. So the services that requires high availability, that has a very high disaster recovery cases, like you might potentially want to run an active. That's where you pull your DSQL tool out of your toolbox. And if you don't need all of that, maybe you're better off with just a regular RDS. Definitely cheaper.
Yeah, but price isn't available, at the moment. It's preview.
Yeah,
preview.
I mean, I would imagine you would have to pay. You would have to pay for all of this goodness.
Why else this benchmark don't make sense to me? Because there's only one metric which available in preview. So it's a bit harder to actually take a look. Yeah, I can do it with the Postgre engine itself. I can grab it an export to Prometheus, but in a preview, we have only approximate cluster storage, and that's it. There is no more metrics, so it's a bit more difficult to understand. What else I find in use? It with Amazon files like for subsea cable from Ireland to US. So maybe it's for Aurora DSQL, which require, high throughput and low latency. Who knows? But it's interesting that Amazon is going to own the entire cables under the sea. At the moment, they share ownership with some other companies, but this one, I think, will be like a full ownership of a cable under the sea. So it's a huge commitment. I think Aurora DSQL will be compared to another distributed always on systems which are available at the moment in the world, like as Google Spanner, IgByteDB, or CockroachDB. I myself, I tried CockroachDB. I read their book. I understand how the underlying infrastructure system work, how architecture works. It's pretty impressive. But developers who try to use CockroachDB consider it's a bit slow for them, at least. And another concern is where is the data? If we host it inside CockroachDB Cloud, we have to, move data out AWS to somewhere else, maybe to another AWS accounts, to concerns, or we have to host it ourselves and manage that. We want to do this. So I think DSQL will find the place. The use cases, especially for DSQL. So yeah, it's as Andrei mentioned, like as if you need an active replication, if you need a multi-regional approach, if you need a global infrastructure, like as for payment services, kind of global ledgers or market orders, storage, kind of that. And if you have regulations which force you to store data in multiple regions, and if you have clients in multiple regions, it could be a good choice. For healthcare,
I'm sorry for interrupt. Like, if you have regulations that require multi-region, you could still do with active passive. You don't really need to do active all the time. So, like, you can do the backup to another region and be done with a single RDS instance, not even a cluster. But if you have a critical system with very high SLA requirements from your customers, and you need active, yeah, that's probably the missing piece that was not available in AWS before, and was kind of missing out here for compared to Google Spanner. And now they're trying to close this gap. So that's very welcome move by Amazon.
And I think just my own theory and idea, like as how the system could appear, because all of us know Amazon.com website, and we know that in e-commerce, in this retail world, there are promotions, and promotions usually limited. You have some amount of items in stock, maybe 100 items for specific price, and you would like to sell from the customers who come first. And as we remember, this Aurora DSQL is make everything in the commit phase, and during the commit, we commit the transaction which comes first, like as who buy the item on this promotion price first. It's committed to the database, and the rest it's have to retry and double check if the promotion price is still available. If not, you not get the promotion price. So it's a maybe interesting use case for a global shopping carts and for global, retail in services.
Just for my understanding, like when you have this retries happening, that means that you will have a retry, like the application will have to retry the transactions, not the database is trying to retry the transaction. The application will get the error and would need to retry the query it did.
If I understand here correct, it's a database which have to retry your query, not the application. And the idea of DSQL and a strong consistency that we let developers to write applications easier and rely mostly on the database. And I also see that Amazon is moving from eventual consistency to a strong consistency. Like as I saw the same in MemoryDB. MemoryDB is also offer strong consistency. So, and I think it will be really easier. Eventual consistency, I think, is just hard to understand. You have to double check, is data there or not yet, or when. But with a strong consistency, you can write code easier. Data is always there. And also for my own suggestions, I would like to say that we already use many different database types and options, even in one application. For example, we already store cache inside the Redis, some big static objects in S3. When we have many different data storages for different purposes, it already exists. So why not use Amazon Aurora, for example, for your users tables, Aurora Global Database, for example, when we can wait when requests come to another region, and Amazon Aurora DSQL just for financial transactions, or something that's really important, just for a piece of the data,
Yes.
but not everything.
Yes.
So, and I can suggest to use a different database types for different use cases. Like as we have a microservice architecture, and different microservice can use a different instance from the Amazon Aurora family. So whatever options is available, choose the best what you need. So yeah, this is all the slides, I believe. Yep. No more.
Oof.
Yay! We make it done.
That doesn't sound like 20 minutes, though. But it still was a lot of good content.
But you know how Office appear? It's actually community organizers in Singapore. They tell, oh, please make it a bit more technical. Our audience like a technical topic. Please make it more level. But I'm not that much familiar with Amazon levels. So 100, 200, 300, 400. I think I have only two modes. One mode make it simple. One mode make it deep. So I not achieve that difference. So I have two options.
Next time they will be clever about what they're asking for.
Yes.
Anyhow, I hope those of you who watched till the end, thank you very much.
Yes.
Like, subscribe, do whatever you're supposed to do on YouTube, and we see you in the next video. Thank you for the day.
Yay! Thank you for watching.
Bye bye.
Bye bye.